This is an Edexcel GCSE Chemistry Paper 2 higher tier from June 21. Figure 1 shows a list of particles. In the space below, write the names of these particles in order of increasing particle size. So let's work out first of all what would be the smallest. That would be the sodium atom because it's a single atom. Then we'd have the ethene molecule because remember that's C2H4, so again not a very large molecule. After that you would have a starch molecule. And then actually the largest thing here would be the nanoparticle. Even though nano means very small, it still wouldn't be as small as the other things here. Explain a possible risk associated with nanoparticulate materials. Firstly, we don't know what the risks are long term because not enough time has passed. Secondly, we don't know if they could pass through the body and enter our bloodstream and then cause changes to the reactions inside our cells. So that could be potentially very dangerous. So either of those answers is fine. Explain the advantage of using catalysts made of nanoparticles rather than larger particles. So the main advantage here is that you get a much larger surface area when you use nanoparticles. And why is that good? Because there's an increased frequency of successful collisions, so an increased reaction rate. The concentration of a solution can be calculated using the equation concentration equals mass divided by volume. A student dissolved 9.25 grams of ammonium chloride into water and made up the solution to a volume of 200 centimetres cubed. Use the equation to calculate the concentration of this solution in grams per decimetre cubed. So the first thing to notice is the units for volume. We need to get 200 centimetres cubed into decimetres cubed. How do we do that? By simply dividing by 1,000. So now we're ready to find that concentration. So the mass we were told is 9.25. The volume is 200 divided by 1,000. 46.25 is our final answer. Dissolving ammonium chloride in water is an endothermic reaction. That means our delta H is positive. Figure 2 shows part of the reaction profile for this process. Explain how Figure 2 shows that dissolving ammonium chloride in water is an endothermic process. So the main thing here is that our product, the ammonium chloride solution, has more energy than our reactants, the ammonium chloride solid and water. And therefore that energy change here, if I was to draw it on, as I've already said, is positive. And that indicates therefore that heat energy has been taken in, which is our definition of an endothermic reaction. So the products have more energy than the reactants. The heat energy, so delta H, has increased. And therefore heat energy has been absorbed. Complete the reaction profile in Figure 2 and label the activation energy. So remember we need to show that peak. And if I actually remove this, the activation energy is drawn from the reactant's energy level to the top of that peak. So there is your activation energy. Make sure you read every question. It'll be very easy to miss part 2. A student used the equipment in figure 3 to investigate whether electricity can pass through solid ammonium chloride and through ammonium chloride solution. I already know that it won't pass through ammonium chloride solid, but it will through the solution because the ions are free to move in the solution. If an electric current flows in the circuit, the lamp will light up. And just as we thought, with the solid, the lamp did not light up. With the solution, it did light up. Explain the results. So it's all to do with the ions and whether they're free to move or not. So first of all, we say that ammonium chloride solution contains ions which are free to move. Meaning that it conducts electricity, hence why the lamp lit up. The ammonium chloride solid has no free ions. And therefore cannot conduct electricity. Diesel oil is a mixture of hydrocarbons that can be obtained from crude oil. State the name of the process used to separate diesel oil from crude oil. This is fractional distillation. Diesel oil contains alkanes. These alkanes are part of a homologous series. Which statement about compounds in this homologous series is true? They have the same chemical formula. No, that won't be true because it will vary depending on how many carbon atoms they have. They have the same empirical formula. Again, that's not true because if you take methane, CH4, for example, and ethane, C2H6, the empirical formula of ethane is CH3, which is not the same as methane, CH4. They have the same general formula. Yeah, that's true because they're both CnH2n plus 2. They have the same molecular formula. No. If we look back at this, this is the molecular formula of methane, molecular formula of ethane. They are not the same. When fuels such as diesel oil are burned, the high temperatures produced can cause nitrogen and oxygen in the air to form the pollutant nitrogen dioxide. Complete the balanced equation for this reaction. So we're making nitrogen dioxide, di meaning 2 oxygens. Now we just need to make sure it's balanced. I'm going to pop a 2 there because we have 2 nitrogens on the left-hand side. Now we have 2 on the right. 4 oxygens on the left-hand side, 4 on the right. Explain how the greenhouse effect is caused by the gases produced by the complete combustion of diesel oil. So complete combustion means that you have a plentiful supply of oxygen, meaning that carbon dioxide and water are produced as byproducts. And these are greenhouse gases because they absorb heat radiated from the earth and re-radiate it back into the atmosphere, causing that warming effect, global warming. This question is about polymers. State a problem with recycling polymers. So this is what to do with plastics. Now the problem is if you've got PVC or polythene or polypropylene, these are all different polymers and so they need separating first of all. It takes time to do this. Lots of them aren't actually recyclable and this whole process requires a lot of energy. I'm actually going to choose the answer which is some polymers are not recyclable. And then this time we're being asked about the disposal. Now, lots of them are non-biodegradable. So what that means is they don't break down and they occupy landfill sites, which is obviously a huge issue. Polychloroethene is a polymer made from chloroethene. A molecule of chloroethene is shown. On figure 5, draw a circle around the functional group of this molecule. It's the C double bond C here. Draw a section of polychloroethene molecule containing 3 repeating units showing all the bonds. Okay, so what you have to do here is take that original monomer, break the double bond, add all the other atoms back in. There's my first one, and it's asked for 3, so I'll just copy it across again for the second time, and then the third time, and then let's just add a few extra long bonds to show that that molecule continues. What type of polymer is polychloroethene? It's an addition polymer. What does that mean? It means those monomers have been added together in order to form the polymer. Calculate the relative formula mass of polychloroethene molecule made from 2,850 chloroethene molecules, C2H3Cl. Here are our relative atomic masses. Give your answers to 3 sig fig, show you're working. So let's first of all find the relative formula mass of one molecule. 12 times 2 plus 3 lots of hydrogen plus chlorine to get an MR of 62.5, and then because we have 2,850 of them, you end up with this big number here, but we need our answer to 3 significant figures, so it becomes 178,000 is our final answer. This question is about potassium and zinc. Which of the following temperatures is most likely to be the melting point of potassium? So remember, for a metal, because it's in group 1, it has quite a low melting point. However, it's still a solid at room temperature, which is why we get rid of these 2 options. We're going to pick C here. Explain how the electronic configuration of an atom of potassium is related to its position in the periodic table. This is all to do with the number of electrons in the outer shell. So potassium has 1 electron in its outer shell, meaning it's in group 1. And then if you look at it here, so we've already talked about the fact that it has 1 electron in its outer shell, so it's in group 1. Let's write out its electronic configuration. So it's 2, 8, 8, 1. So it means it has 4 shells of electrons, meaning that it is in period 4. And we can count that down. 1, 2, 3, 4, and there it is, in period 4. So K has 4 shells of electrons. So it's in period 4. Potassium reacts with oxygen to form potassium oxide. Describe the test to show that the gas is oxygen. The simplest way of saying that is that it relights a glowing splint. And you will get 2 marks by saying that. Potassium oxide is ionic. Write the electronic configurations for the ions in potassium oxide K2O. So remember, potassium was 2881. Potassium ion has lost an electron, which is why we lose that final electron there. Now oxygen has this electronic configuration. The oxygen ion is O2 minus, which means it's gained 2 electrons to gain that full outer shell. So that's why those are the answers. Figure 6 shows 2 gas syringes connected by a glass tube. Inside the glass tube there are some pieces of zinc. Zinc reacts with oxygen at a temperature over 225 degrees. Not all the oxygen reacts at once. The oxygen reacts only when in contact with the zinc. Devise a plan to find out the volume of oxygen contained in a known volume of air using the apparatus shown in figure 6. So we're using all the information they've provided. First of all, we'll obviously need a Bunsen burner, heating up that zinc to over 225 degrees. We'll then want to run a specific volume of air, let's say 100 centimetres cubed. We want to push that air over that heated zinc, backwards and forwards, and we know that that oxygen in the air will react with the zinc, forming zinc oxide, and then we repeat that until there's no change in volume, and then that will enable us to find the volume of oxygen contained within the known volume of air. This question is about the rate of reaction between calcium carbonate and hydrochloric acid. This is the word equation. Which of the following is the formula for calcium carbonate? So you can either learn that off by heart or use the ions to work out that it's CaCO3, option B. Some pieces of calcium carbonate were added to dilute hydrochloric acid in a conical flask and the volume of carbon dioxide produced was measured. Complete the diagram in figure 7 to show the apparatus to collect the gas produced and measure its volume. Oh no, I hate drawing. Okay, we definitely need a bung, but we also need a delivery tube. So there's our bung. And so we know that carbon dioxide will be released. It will bubble up here. And then we need a gas syringe. Oh no. You know what? That could be a lot worse. And then let's hold our gas syringe in position using a clamp stand. Always label everything. You could also shown downward delivery because carbon dioxide is such a dense gas, but that is really beyond my drawing skills. The reaction between calcium carbonate and dilute hydrochloric acid was investigated at different temperatures. State what could be used to keep the temperatures of the conical flask and its contents at a temperature of 45 degrees throughout the reaction. You want to use a conical flask placed in a water bath. Figure 8 shows a graph of volume of gas collected in this investigation. Draw a tangent at 100 seconds on figure 8. Use this tangent to calculate the rate of reaction at this time. So there's 100 seconds. Let's draw our tangent. So as you can see, I've drawn my tangent here. Then I've completed the triangle so that I'm able to find the gradient of that tangent, which remember is the change in y, which is 50, divided by the change in x, which is 175, to get 0.286 to 3 significant figures. The temperature of the acid was kept at 45 degrees. State one other variable that needs to be controlled during this investigation. Lots of options here. I'm going to say the concentration of the acid. You could have also talked about the volume of acid, the mass of calcium carbonate, the particle size. Explain in terms of particles how decreasing the temperature affects the rate of this reaction. So let's first of all say that decreasing temperature decreases the rate. And then we're going to say why. Because the particles have less kinetic energy So there is a decreased frequency of successful collisions. A technician was asked to find the concentration of potassium ions in dilute solution using a flame photometer. The technician first produced a calibration curve using solutions with known concentrations of potassium ions. Figure 9 contains the data for the calibration curve. Use the information Figure 9 to plot the curve on the grid below. So as you can see here, I've picked sensible scales. We're going from 180 to 900, so I'm going to make sure I'm occupying a large amount of the graph paper on this side, and then on the x-axis we're going from 0.025 up to 0.5. Again, that's the sensible x-axis scale, and now we can plot. So 0.025 and 180, that's done. 0.05 and 280, 0.1 and 440, 0.2 and 580, 0.5 and 900. There's my graph line, so I'm quite pleased with that. The technician then obtained a reading of 360 for a dilute solution containing potassium ions. Use the calibration curve to find the concentration of potassium ions in this solution. That means reading across at 360, and then read down here. So that's around 0.07. In the test for chloride ions, silver nitrate solution is added to a solution containing chloride ions. A white precipitate forms. Write the ionic equation. So there's our chloride ion. It's reacting with the silver of the silver nitrate solution to form a white precipitate of silver chloride. And then just add your state symbols and check that it's balanced, which it is. A student was given a container of ammonium iron 2 sulfate. The student was also given a dilute solution of sodium hydroxide and access to other laboratory reagents. Describe the tests the student should carry out to identify the ions in the ammonium iron 2 sulfate, including appropriate equations for the reactions. Wow, there's an awful lot here. So we have ammonium ions, we have iron 2, and we have sulfate. So let's talk about them one by one. Let's test for the ammonium ions first of all. Remember, you want to add sodium hydroxide, which handily they've already mentioned in the method. You get a choking gas produced, which should be ammonia. And then you confirm this by holding the gas over damp red litmus paper, which should turn blue. And the equation, do not forget to answer all parts of the question, would be this. So that's ammonia done. What about iron 2? Again, we add sodium hydroxide. What will you see this time? No gas. Instead, you get a green precipitate is formed. So you must learn these colours. And your ionic equation looks like this. Make sure it's balanced. And then lastly, your test for sulfates. This time you want to add hydrochloric acid and barium chloride. You can write it out in full if you prefer. A white precipitate indicates sulfate ions. And then finally that equation. There's your barium ions reacting with your sulfate ions to form your white precipitate of barium sulfate. This question is about some of the elements in group 7 of the periodic table. Which row in the table correctly shows the colours and physical states of the elements at room temperature? Right, iodine has the highest melting point, and it is a dark grey solid at room temperature. So this line here is correct. Yes, iodine does sublime and become a purple gas, but that is not happening at room temperature. And then let's just check that we're happy with bromine as a red-brown liquid. Yes, we are. The compound phosphorus oxychloride has the formula POCl3. Calculate the percentage by mass of chlorine in this compound. So this is the formula effectively we need to use. So we have 3 lots of chlorine. And once you put that in, you get 69.4%. When iron reacts with chlorine, iron chloride is formed. 2 possible equations for this reaction are: in an experiment, 8.4 grams of iron reacts with chlorine to form 19.05 grams of iron chloride. Show using a calculation which reaction A or B is taking place. You must show your working. This is so interesting. Right, let's take A. So we're going to use the table format to help us here. It's my favourite way of doing more calculations. And we're using this formula triangle over here. So we know that we have a mass, an MR, and a number of moles we need to find. So the mass is 8.4 grams. And we need to find this mass over here. So that if this number here matches that, then we know A took place. And if it's a different number, then we can infer that B took place. So what's the atomic mass of iron? We've been told it's 56. So that's 0.15. Check the mole connection. It's 1 to 1, so we can take that 0.15 over here. What's the MR of iron chloride? Well, we do 56 plus 2 lots of chlorine to get 127. And then lastly, to find our mass, we do MR times number of moles. Ooh, and happy days. Look, that answer is 19.05, which is the number they've given us. So A took place. So that worked out very nicely indeed. Group 1 metals react with the elements from group 7 to form salts. Some examples of these reactions are shown. You'll find the position of these elements in their groups on the periodic table, explain in terms of their electronic configurations and the relative reactivity of these elements. Which of the reactions shown in figure 10 would be the most violent? Let's first of all think about the fact that with group 1 metals, the lower down the group, the more reactive the metal. So if you look down here, we have lithium, potassium, rubidium. If you use your periodic table, you'll see that rubidium sits at the bottom and therefore is the most reactive. So in terms of reactivity, it goes is rubidium is more reactive than potassium, which is more reactive than lithium. However, for group 7, the opposite is true. Higher up the group, the more reactive the halogen. So if we have a look at what we've been given, we've got chlorine, fluorine, iodine and bromine. So actually the order of reactivity goes fluorine, chlorine, bromine, iodine, because fluorine is at the top of that table. So really, the most reactive combination we could have is rubidium with fluorine. But if you look down here, you've actually got the most reactive metal with the least reactive non-metal. So that means that Y can't be the most reactive. So actually, look at this one, potassium and fluorine. Okay, it's not, potassium isn't the most reactive, but it's pretty good, look. Fluorine is definitely the most reactive. So actually, we're going to pick X. X would be the most violent. And then we need to explain this in terms of electronic configurations. So potassium is very reactive because it is a large atom with many shells of electrons. So outer shell electrons are far from the nucleus and more easily lost. To form the all-important K+ ion. Now we need to argue why fluorine is the most reactive halogen, because it is very small, so it has few electron shells. So the outer shell electrons this time are more tightly attracted. And it is more easy to gain that final electron. To form the all-important F- ion. And by doing that, I have well and truly answered the question. Pentadecane is a hydrocarbon used as a fuel. The incomplete combustion of pentadecane produces carbon monoxide. Carbon monoxide is a toxic gas. Explain why the incomplete combustion of pentadecane can produce carbon monoxide as one of the products. Well, remember that incomplete combustion means that there's insufficient oxygen, and that's needed to oxidize the carbon to carbon dioxide. So without that, we only get oxidation to carbon monoxide. Explain how carbon monoxide behaves as a toxic gas. It combines irreversibly with hemoglobin in red blood cells. Therefore stopping the transport of oxygen. 1 mole of pentadecane can be cracked to form 1 mole of octane and 1 mole of propene and 2 moles of another product. Complete the balanced equation for this reaction by adding the formula of the missing product. So we actually need to add up how many carbons we've got. We've got 8 plus 3, which is 11. Therefore left over is 4, but we've got this big 2 there, which is why we actually only need 2 carbons. Let's work it out now for hydrogen. We've got 18 plus 6, which is 24. The difference between 32 and 24 is 8. Again, we've got that big 2, so that's why it's C2H4. Ethene. Figure 11 shows the reaction of propene with water. Figure 12 shows some bond energies. Use the bond energies to calculate the energy change of the reaction. Let's write out the equation. So to find that energy, we do bonds broken, take away bonds formed. So let's work out our bonds broken on this side first of all. Let's count them off. 1, 2, 3, 4, 5, 6 CH bonds. One C double bond C. One C single bond C. And then 2 OH bonds. And I really recommend marking them off so you don't miss them. And then it's a matter of putting all these numbers into your calculator and adding them all up to give 4,365. What about bonds formed? Got 2 C single bond Cs. One, 2, 3, 4, 5, 6, 7 CH bonds. One OC bond. And one OH bond. add these up as well. That's 4,407, and then finally 4365 minus 4407. Let's get minus 42 as our final answer. Methane gas was burned using the apparatus shown in figure 13. Explain why water droplets form on the bottom of the beaker of cold water. So where would that water come from? Well, if you take your methane, you burn it in oxygen, completely combust it to form carbon dioxide and water. So why does that water form? Because water forms in the complete combustion of methane. And where do the droplets come from? Because that vapour has condensed on the cold surface of the beaker. Propanol can undergo reactions to form compounds Y and Z, shown in figure 14. What happens to propanol when it forms compound Y? So that propanol is losing water, so it becomes dehydrated. Compound Y can also be formed in the following reaction. Explain how bromine water can be used to distinguish between compound X and compound Y. So this is an alkene. This is an alkane. So bromine water decolorizes with an alkene and stays orange with an alkane. And you can draw whole equations to prove this, but we're just going to say bromine water added to Y turns from yellow to colourless. Bromine added to compound X stays yellow. Compound Z is a carboxylic acid. Which of the following is the functional group of a carboxylic acid? Practice drawing this. Remember, each carbon forms 4 bonds. Oxygen always forms 2. Hydrogen forms 1. Which one matches? It's C. Compound Z is an acid and turns litmus and universal indicator papers red. Compound Z also shows other acidic properties. Devise an experiment that would show another acidic property of compound Z. So we know it's an acid. Let's add Z to limestone, so calcium carbonate, and you would expect to see bubbles of carbon dioxide gas being produced. You could have also measured the pH, and the pH should have been less than 7. You could add it to an alkali and produce a neutral solution. The balanced equation for the production of ethanol from the carbohydrate sucrose is: calculate the minimum mass of sucrose needed to produce 29.6 grams of ethanol. Okay, we're going to use the table again. So we're after the mass of sucrose. We've been told we have 26.9 grams of ethanol. What about the MRs? We've been kindly given those right here. So 342 for sucrose, 46 for ethanol. We can now find the number of moles of ethanol by doing mass divided by MR. So that's 26.9 divided by 46 to get 0.5847. Check the mole connection. It's 4 to 1. So to find the number of moles of sucrose, we divide that number by 4. And then finally, to find X, we multiply the MR by the number of moles to get 49.99, blah, blah, blah. So that's 50 to 2 significant figures. Calculate the total number of atoms in 10 grams of sucrose. Here's your relative formula mass and Avogadro's constant. So first of all, find the number of moles by doing mass divided by MR. Then you want to multiply it by Avogadro's constant, but be careful, it says the number of atoms, so you also need to add up how many atoms there are here. So that's 12 plus 22, which is 34, so that's 45. So our final answer is 7.92 times 10 to the 23 to 3 sig fig. Bye.